Space is not just stars and planets. It is a gallery of cosmic oddities, each more baffling than the last. This is a countdown of the 25 strangest objects ever discovered, from rogue worlds to structures so vast they defy logic. By the end, you will have toured the most extreme and mysterious corners of reality. We will encounter a star that dims like a machine and a void so empty it should not exist. What do you think is waiting for us in the dark? Our journey begins not with a strange object, but with a strange absence. Number 25 on our list is the Boötes Void, a region of space so profoundly empty it has earned the nickname the Great Nothing. Picture the universe as a vast cosmic web, with galaxies strung along glittering filaments like dew on a spider's web. Now, imagine a tear in that web, a spherical hole nearly 330 million light-years wide. Within that staggering volume, astronomers expected to find thousands, perhaps even tens of thousands of galaxies. Instead, they have found only a handful, scattered like lonely outposts in an endless, dark desert. This is not just an empty patch, it is a cosmic supervoid of terrifying scale. If our own Milky Way sat at the center of the Boötes Void, we would not have known other galaxies existed until the 1960s. The night sky would be almost black, a profound and isolating darkness. Its discovery was a shock, a direct challenge to our models of how matter is distributed across the universe. How could something this vast be so empty? Is it simply a statistical fluke, a one-in-a-million chance in the grand lottery of cosmic structure? Some theorists propose a more dramatic origin, that the void is the scar of a collision between universe-sized bubbles in the early cosmos, a phantom bruise on the fabric of reality. Or perhaps it is something else entirely, a place where the rules are subtly different. The Boötes Void stands as a haunting reminder that emptiness on a cosmic scale can be just as strange and unsettling as any object. It is the silence between the notes, a silence so deep it asks a screaming question. What else is missing from our map of the heavens? That profound emptiness makes the sudden appearance of a flickering light all the more startling. At number 24, we have a star that refuses to behave. Officially catalogued as KIC 8462852, it is far better known as Tabby Star, named for the astronomer Tabby Star who led its investigation. This otherwise ordinary star, over 1,000 light-years away, became an internet sensation and a scientific enigma because of one simple fact: it keeps winking at us. Data from the Kepler Space Telescope revealed its light was not just dimming in the regular, predictable rhythm of an orbiting planet. Instead, it plunged by staggering amounts, up to 22% at times, as if something colossal and jagged was drifting in front of it. A planet, even a gas giant, would only block about 1% of a star's light. This was something else entirely. The dips were deep, irregular, and asymmetric, like watching a shadow theater where the shapes make no sense. The most tantalizing and headline-grabbing hypothesis was that of an alien megastructure. Perhaps an advanced civilization was building a Dyson swarm, a vast collection of energy-collecting panels encircling their sun, and we were seeing the incomplete, clunky silhouette of their construction project. It was a perfect cosmic mystery, blending hard data with science fiction dreams. Yet, as astronomers turned every available telescope toward Tabby Star, more natural explanations emerged. The leading theory now suggests a chaotic swarm of exocomets, shattered remnants from a catastrophic collision, or a vast, uneven ring of fine dust and debris orbiting the star. This dust, unevenly distributed, could create those bizarre, deep dimming patterns. The star itself may also be prone to extreme outbursts, adding to the erratic light show. While the alien megastructure idea has largely faded from scientific favor, the mystery is far from solved. What exact process creates such extreme and irregular shadows? The investigation continues, powered in part by a massive citizen science project where thousands of people sift through data, looking for patterns machines might miss. Tabby Star stands as a monument to a new kind of discovery, where the line between natural wonder and science fiction blurs, and where everyone can help stare into the darkness searching for an answer. The search for answers beyond our solar system took a dramatic turn when a visitor arrived from the deep. At number 23, we have the first known interstellar tourist, an object named Oumuamua. In the Hawaiian language, its name means scout or messenger from the distant past, a fitting title for a rock that had been traveling between stars for possibly hundreds of millions of years before it streaked through our neighborhood. Its discovery in 2017 was a historic moment, the first tangible proof that material from other star systems routinely passes through ours. But this was no ordinary asteroid. Everything about it was strange. First, its shape. Based on the wild variations in its brightness as it tumbled, scientists deduced Oumuamua was not round. It was elongated, perhaps 10 times as long as it was wide, resembling a cosmic cigar or a flattened pancake tumbling end over end through the void. This was already unusual, as most solar system objects are more lumpy than slender. Then there was what it lacked. As it approached the sun, astronomers watched closely for signs of outgassing, the telltale halo of gas and dust that forms a comet's glowing coma. Oumuamua showed no coma. It appeared to be a dry, inert rock. Yet as it swung around the sun and began its exit from our solar system, something inexplicable happened. Its trajectory showed a slight but definite acceleration, a push that could not be accounted for by gravity alone. This is the classic behavior of a comet, where evaporating ice acts like a natural rocket engine. But where was the gas? Where was the dust? The silence was deafening. This single observation ignited a firestorm of scientific debate that continues to this day. One compelling theory suggests Oumuamua was a chunk of solid nitrogen, a kind of cosmic iceberg that had been sheared off the surface of a Pluto-like world in a distant system. As sunlight warmed it, the nitrogen would have sublimated directly from solid to gas, providing the thrust without producing the dusty debris of a water ice comet. Another idea proposes it was a hydrogen iceberg, a fragile object that could have formed in the cold heart of a giant molecular cloud. Yet others argue for more exotic, but still natural, explanations involving clouds of dust particles or the effects of solar radiation pressure on a very lightweight object. Of course, the acceleration also fueled more speculative ideas, including the possibility of a thin light sail of artificial origin. The truth is, we may never know for certain. Oumuamua is now far beyond the reach of our telescopes, a faint speck receding into the interstellar dark, taking its secrets with it. Its brief, enigmatic visit was a gift and a taunt, a proof that the galaxy is full of travelers, and a reminder of how much we have yet to learn about their true nature. It was a messenger that delivered only one clear message: the universe is far weirder than we imagined. That fleeting interstellar visitor is a stark contrast to a structure of almost impossible permanence. At number 22, we find a geometric wonder locked in the clouds of a gas giant. This is Saturn's north polar hexagon, a perfect six-sided jet stream that has whirled for decades, perhaps centuries, in a display of atmospheric artistry. Seen from above by the Cassini spacecraft, it resembles a colossal honeycomb cell painted onto the planet's swirling tan and gold cloud tops, a shape so precise it looks engineered. The scale is humbling. Each side of the hexagon is wider than the Earth's diameter, and the entire structure is so vast you could comfortably fit 4 of our entire planet inside its boundaries. This is not a solid object, but a persistent, high-speed river of wind, a 6,000-mile-per-hour atmospheric highway tracing its angular path. The sheer stability of this shape is what baffles scientists. On Earth, weather systems are chaotic and transient. but this hexagon has been observed holding its form since the Voyager flybys in the 1980s. It is a planetary tattoo that refuses to fade. The explanation lies in the strange physics of fluid dynamics. Think of it as a giant, self-organizing standing wave. In laboratory experiments, when a fluid is rotated in a circular container, under the right conditions, stable polygonal shapes can form within the swirling mass. Scientists believe something similar is happening deep in Saturn's atmosphere. The planet's rapid rotation, combined with differences in wind speeds at various latitudes, may be setting up a resonant wave pattern. This pattern, like a vibration frozen in the air, manifests as this six-sided jet stream with a massive, churning hurricane pinned directly at its center. The Cassini probe's stunning imagery revealed the hexagon's structure in breathtaking detail, showing how clouds whip around its sharp corners, following the invisible tracks of this atmospheric racetrack. It is a natural masterpiece, a demonstration of how simple physical laws operating on a planetary scale can generate geometry of startling perfection. The hexagon is a reminder that nature does not need a blueprint to create order. Sometimes the chaos of a storm, given enough time and space, can dance itself into a shape of breathtaking mathematical beauty. What other invisible patterns are etched into the winds of distant worlds? While Saturn's hexagon is a monument to orderly chaos, some cosmic signals are pure, unfiltered violence. At number 21, we encounter a scream from the dark, a phenomenon so powerful it outshines entire galaxies for a fleeting instant. These are fast radio bursts, or FRBs, and the most famous among them is a repeater known as FRB 121102. Imagine, if you can, a flash of radio light. In less time than it takes to blink, a single burst releases more energy than our sun will emit in 80 years. It is a pulse of raw power so intense it can be detected across billions of light years, a brief, brilliant shout in the cosmic radio static. For years after their discovery, these bursts were frustrating one-off events, cosmic lightning strikes that appeared and vanished without a trace, leaving astronomers to wonder if they were cataclysmic finales, the last signal of a star being shredded by a black hole or neutron stars colliding. Then came FRB 121102. This one did something extraordinary. It repeated. It flashed again and again, on no schedule we could discern, proving that whatever engine was powering these bursts was not destroyed in the act. It was a machine that could fire more than once. Pinpointing its source was a triumph of modern astronomy, a global effort using the world's most powerful radio dishes. The signal was traced back to a tiny, faint dwarf galaxy over 3 billion light-years away. Not only that, but it was coming from an incredibly turbulent neighborhood within that galaxy, a region brimming with energetic particles and powerful magnetic fields, possibly near a supermassive black hole or within a ferocious stellar nursery. This environment is a key clue. The leading suspect for creating such monstrous, repeating bursts is a type of stellar corpse called a magnetar. Picture a neutron star, the collapsed core of a giant star, but with a magnetic field 1,000 trillion times stronger than Earth. It is the most powerful magnet in the universe. Theorists suggest that starquakes on the surface of a young, hyperactive magnetar or sudden magnetic reconnection events could unleash these titanic radio shocks. The repeating nature of FRB 121102 means we can watch and wait. We can point our telescopes at its home galaxy and catch it in the act over and over, studying its polarization, its frequency, and its structure. Each new burst is a piece of the puzzle, helping us rule out theories and refine our models of the most extreme physics in the cosmos. These flashes are not just mysterious signals, they are natural laboratories, allowing us to probe the conditions around some of the universe's most volatile and enigmatic objects. They are lighthouses in a storm of magnetic fury, and with each repeated pulse, they slowly illuminate the machinery of the abyss. That magnetic fury is a forge for the universe's most extreme objects. At number 20, we find a world born from stellar cannibalism and crystallized into a cosmic jewel. This is the Diamond Planet, officially known as PSRJ 17191438b. It orbits not a normal star, but a pulsar, the rapidly spinning corpse of a supernova, over 4,000 light-years away. The story of its creation is one of cosmic destruction and alchemy. Astronomers believe this planet was not always a glittering sphere. It began as the carbon-rich core of a massive companion star. For eons, the pulsar, a tiny but incredibly dense and energetic object, siphoned material away from its neighbor, stripping the star down layer by layer until only its heart remained. This remnant core, robbed of its outer gases, was left as a planet-sized ball of incredibly dense carbon, still orbiting its voracious partner. Then physics took over. Under the immense gravitational pull of the pulsar and the titanic pressures within its own body, this carbon underwent a radical transformation. The same process that turns coal into a diamond in Earth's mantle was enacted on a planetary scale. The carbon atoms were compressed and heated until they locked into a rigid, crystalline structure. The result is a world that might literally be a diamond, an exotic gemstone perhaps 5 times the size of Earth. Imagine a mountain range of pure, faceted crystal, or an entire continent with the refractive brilliance of a cut stone. The surface gravity would be crushing, and the sky would be dominated by the relentless, lighthouse-like beam of the pulsar, sweeping across the crystalline plains every few minutes. While we cannot see its glitter directly, its existence is inferred from the incredibly precise timing of the pulsar's radio pulses, which wobble slightly due to the planet's gravitational tug. This diamond world is a testament to the universe's capacity for bizarre refinement. It is a tombstone for a dead star, polished by gravity and pressure into the most extravagant grave marker imaginable, a permanent monument to a cataclysm that forged beauty from annihilation. What other treasures are hidden in the graves of stars? A diamond forged in stellar death is a marvel, but some cosmic relics hide an even deeper mystery in what they lack. At number 19, we encounter a galactic fossil, the ancient cannibal known as NGC 1277. This galaxy, a massive elliptical blob over 200 million light-years away, is not strange for what it contains, but for what it appears to be missing. It is a living snapshot of the universe in its raw, early youth, having essentially shut down its star production over 10 billion years ago. While other galaxies continued to evolve, merge, and light up with new suns, NGC 1277 became a cosmic time capsule, a dormant giant. Its stars are all old, red, and quiet, a population frozen in time. Yet its greatest anomaly emerged from detailed studies of its motion. To hold itself together, a galaxy of this size and mass should be embedded in a huge, invisible halo of dark matter, the mysterious gravitational glue that binds the universe. But the stars in NGC 1277 move in a way that suggests there is almost no dark matter there at all. This defies everything we think we know about how galaxies form. According to our standard models, galaxies are born within clouds of dark matter. The normal matter, the stuff that makes stars and planets, simply falls into its gravitational wells. So how does a galaxy this big exist without its dark matter skeleton? Astronomers are grappling with 2 unsettling possibilities. The first is that this galaxy somehow never acquired its dark matter halo in the first place, a cosmic oversight that would force us to rewrite the story of galactic infancy. The second, more violent idea is that it was stripped clean. Perhaps NGC 1277 was once a normal galaxy that plunged through the dense core of a massive galaxy cluster. In that brutal gravitational environment, tidal forces could have ripped away its dark matter while leaving the more tightly bound stars largely intact, like a thief stealing the frame from around a painting but leaving the canvas behind. This would make it a cannibal that got cannibalized, a victim of a larger cosmic feast. This relic galaxy offers a unique and challenging window. It is not showing us how things are, but how they might have been under different, more extreme rules. It poses a fundamental question: are we looking at a failed galaxy, a rare survivor from an era when the universe worked differently, or is it a stark lesson in the violence of galactic interactions? Its silent, ancient stars hold a secret that could reshape our understanding of the invisible foundation of the cosmos itself. Our understanding of galactic evolution is built on collisions and chaos, but one celestial structure defies that narrative with serene, perfect geometry. At number 18, we find Hoag's Object, a galaxy that looks less like a whirlpool of stars and more like a cosmic bullseye. From our vantage point 600 million light-years away, it presents an almost impossible symmetry. At its heart sits a dense, golden sphere of ancient yellow stars, a core that glows with the warm light of stellar old age. Surrounding this core is a perfect, wide ring of brilliant blue, a separate circle of young, hot stars actively being born. Between them lies a profound and seemingly empty dark gap, a clean lane of near-nothingness that separates the two stellar populations like a moat around a castle. It is a structure of such startling clarity and beauty it feels designed, a celestial mandala painted onto the black canvas of space. The mystery is not just its appearance, but its profound stability. How does such a perfect ring form and maintain itself without collapsing or twisting into a spiral? The two leading theories each tell a story of cosmic violence refined into order. The first suggests a galactic collision billions of years ago. A smaller galaxy might have plunged straight through the heart of what was once a normal spiral galaxy. That catastrophic encounter would have sent shockwaves rippling through the disk, triggering a wave of star formation in a perfect expanding circle, while leaving the central core relatively undisturbed. Over eons, the debris and the intruder galaxy itself would have dispersed or been absorbed, leaving only this beautiful ring as a fossilized ripple from the ancient impact. The second theory is more subtle, relying on the strange physics of resonance. Just as a steady rhythm can cause a wine glass to vibrate and sing, a central bar of stars or a lopsided distribution of mass in the galactic core could create a gravitational resonance. This resonance would act like a shepherd, pushing gas and dust into a specific, stable circular orbit far from the center, where it then condenses to form new stars exclusively in that ring. This would make Hoag's Object not a product of a single crash, but of a slow, musical harmony played out over cosmic time. Unlike the grand, messy spirals like our own Milky Way, with their tangled arms and ongoing star birth, Hoag's Object feels frozen and complete. Its separation of old and new stars is so absolute, its form so circular, it challenges our notions of how galaxies can exist. It is a reminder that the cosmos can achieve perfection not just through force, but through balance, a delicate and enduring equilibrium between creation and decay. What other serene and symmetrical wonders are waiting in the deep field surveys, hiding in plain sight? This serene galactic bullseye exists within a universe we assume is expanding evenly in all directions, a fundamental rule called isotropy. But what if, on the largest scales imaginable, the cosmos has a subtle, preferred direction? At number 17, we encounter one of the most profound and controversial mysteries in modern cosmology, the dark flow. This is not the movement of a single object, but the eerie, coordinated drift of entire galaxy clusters, hundreds of them, streaming like leaves caught in a cosmic river toward a single point on the sky. They are moving at staggering speeds, millions of miles per hour, in a direction that cannot be explained by the gravitational pull of anything we can see in our observable universe. The discovery came from a brilliant piece of astronomical detective work, using the oldest light in existence as a backdrop. scientists studied the cosmic microwave background, the faint afterglow of the Big Bang, which fills all of space like a uniform cold bath of radiation. As immense galaxy clusters move through this radiation bath, they create a subtle distortion known as the kinetic Sunyaev-Zeldovich effect. The hot electrons within the clusters scatter the ancient photons, leaving a tiny but measurable imprint, a kind of shadow that reveals both the cluster's speed and direction. When astronomers mapped these imprints for over 1,000 clusters, they found a pattern that sent chills through the scientific community. The clusters were not moving randomly. They showed a coherent stream, all pulled toward a region of space between the constellations of Centaurus and Vela. It was as if some unimaginably vast and distant source of gravity, lying far beyond the edge of everything we can observe, was tugging on the fabric of our entire cosmic neighborhood. The implications are dizzying. One radical explanation points to the multiverse. In some models of cosmic inflation, our universe is one bubble in a frothing sea of other bubble universes. The dark flow could be the gravitational influence of a neighboring bubble universe, a separate reality with its own physical laws, brushing up against our own and exerting a pull across the unimaginable void between them. Another possibility is a colossal, uneven structure from the very earliest moments of our own universe, a texture in space-time so vast its shadow extends beyond our observational horizon. The scientific debate is fierce as it challenges the core cosmological principle that the universe on large scales should look the same in every direction. Skeptics have questioned the data analysis, suggesting statistical flukes or unaccounted for local effects. More recent studies have both supported and contested the original findings, keeping the mystery alive. Whether the dark flow is ultimately confirmed or refuted, its mere proposal forces us to confront the humbling limits of our vision. We map the cosmos from within a finite bubble of light and time. The dark flow hints that beyond our bubble's wall, in the absolute darkness of the unobservable, something immense is waiting, its gravity reaching across the abyss to guide the motion of galaxies. It is a whisper of influence from a realm we may never see, a current in the dark suggesting our universe is not an island, but perhaps just one piece in a puzzle of staggering and terrifying scale. If the dark flow is a current in the cosmic ocean, then the next object is a beacon of impossible geometry shining from the shores of chaos. At number 16, we find the Red Rectangle Nebula, a structure so perfectly angular it seems to defy the very nature of space. Surrounding the binary star system HD 44179, over 2,000 light-years away, this nebula does not billow in soft, ethereal clouds. Instead, it presents itself as a stark, blood-red box with a series of glowing, evenly spaced rungs, like a celestial ladder reaching into nothingness. For decades, its image baffled astronomers, appearing more like a piece of abstract art or a forgotten artifact than a natural formation. The secret to its shape is one of perspective and precision. At the heart of the nebula, two stars orbit one another in a tight dance. One is a dying star shedding its outer layers in a final, desperate act. But instead of expelling this gas in a uniform sphere, the intense gravitational interplay between the two stars funnels the material into two opposing cones, like twin hourglasses of stellar matter. From our fortunate vantage point in the Milky Way, we are looking directly at the side of this double cone system. The edges of the cones form the sharp, diagonal lines of the X shape that defines the rectangle, while the rungs are actually a series of concentric rings, like ripples in a pond, marking pauses in the outflow of material over thousands of years. This creates the illusion of a ladder within a box, a snapshot of episodic death throws frozen in luminous gas. But the red rectangle holds a second, even more profound mystery within its crimson glow. Spectroscopic analysis has revealed it is rich in complex organic molecules known as polycyclic aromatic hydrocarbons. Among them are compounds nicknamed xanthones, molecules that are fundamental building blocks for more complex chemistry. This is not just dust and ionized gas, it is a cosmic chemical factory brewing the very ingredients that, under the right conditions, could lead to the formation of life. Here, in the stark geometric funeral shroud of a dying star, the universe is quietly assembling the pieces of its own potential future. The red rectangle is a masterpiece of cosmic architecture, where gravitational physics carves perfect shapes from stellar death, and within those shapes, the raw materials for biology begin to coalesce. It is a profound reminder that order can emerge from exploration, and that the seeds of life may be sown in the most unexpected and beautiful of graves. A celestial spider spins its lethal web in the constellation Sagittarius. At number 15, we encounter the Black Widow pulsar, a cosmic predator with a horrifyingly apt name. This pulsar, officially known as PSRB 1957+20, is not drifting alone. It is locked in a deadly, intimate dance with a small, failed star called a brown dwarf, orbiting so close they complete a full revolution in just over 9 hours. The pulsar, a city-sized sphere of pure neutron star matter spinning over 600 times per second, is the ultimate vampire. Its twin weapons are relentless. First, its beam of intense radiation, like a lighthouse of pure energy, constantly bathes one face of its companion. Second, and more destructive, is its pulsar wind, a hurricane of high-energy particles blasted outward at nearly the speed of light. Together, they are slowly but systematically cooking and stripping the brown dwarf alive. The effect is both beautiful and brutal. Telescopic observations reveal a vast, glowing cloud of material being boiled off the companion's surface, a comet-like tail of stellar plasma that stretches for millions of miles behind it as it orbits. The pulsar's fierce wind slams into this evaporating gas, creating a shock wave that glows brightly across multiple wavelengths. This is not a quick death, but a slow, cosmic dissection. The brown dwarf is being vaporized, its mass siphoned away particle by particle, some falling onto the pulsar to make it spin even faster, the rest blown out into the void. In a cruel twist of fate, this very process of destruction is what makes the Black Widow visible to us. The evaporating cloud and the shockwave act as a natural amplifier, allowing us to detect the system's faint optical and X-ray glow. Astronomers believe this is a terminal relationship. In perhaps 1 billion years, the companion star will be completely consumed, leaving behind only the sated, rapidly spinning pulsar and a faint, dissipating nebula, the ghost of its last meal. Studying these systems is crucial, for they are natural laboratories for the most extreme physics. They show us the end stage of binary star evolution, a preview of a possible future for many double-star systems. They allow us to measure the incredible power of pulsar winds directly, and to understand how matter behaves under conditions of gravity and pressure we could never replicate on Earth. The Black Widow pulsar is a stark lesson in cosmic intimacy, where the closest bond between two objects can also be a death sentence, a dance where one partner leads the other into oblivion. Our cosmic predator spins its lethal web in the void, but sometimes the universe itself can be the ultimate illusionist. At number 14, we have a celestial mystery that captivated astronomers and then vanished before their eyes, the phantom planet known as Fomalhaut b. Orbiting the bright, young star Fomalhaut just 25 light-years away, this object was a triumph of direct imaging. In 2004, the Hubble Space Telescope captured a stunning picture, a brilliant point of light moving in a graceful orbit around its star, nestled perfectly within a vast, sharp-edged ring of icy debris. It looked exactly like a giant exoplanet, and it was even nicknamed Dagon after a Semitic deity. For years, it was celebrated as one of the first planets ever seen directly, a world caught in the act of clearing its orbital path, a king sitting within its dusty throne. But then, the story took a bizarre turn. Follow-up observations revealed something impossible. The object began to fade, its light dimmed, and instead of a compact point, it appeared to be expanding, smearing out into a diffuse cloud. By 2014, it had simply disappeared from Hubble's view. It was not a planet at all, it was a cosmic ghost, so what had we been watching? The leading theory is both violent and spectacular. Astronomers now believe Fomalhaut b was the aftermath of a cataclysmic collision. Picture two infant protoplanets, each perhaps the size of a large asteroid or a small moon, on a catastrophic collision course within that young system. When they smashed together, the impact would have been unimaginably violent, vaporizing both bodies and blasting a colossal cloud of fine, superheated dust and vapor out into space. What Hubble witnessed was not a world, but the expanding aftermath of that crash, a glittering cloud of debris that slowly dissipated over a decade, fading into invisibility. This phantom planet serves as a profound cautionary tale about the challenges of peering into other solar systems. Direct imaging is incredibly difficult, and sometimes a single snapshot in time can tell a story that is not true. Fomalhaut b was not a stable, mature world, but a fleeting signature of creation through destruction, a single frame from a billion-year-long movie of planetary formation. It reminds us that young star systems are chaotic construction sites, where colossal accidents are not rare events but part of the building process. The dust that once sparkled as a false planet has now likely settled, perhaps coalescing into new, real worlds millions of years from now. The Eye of Sauron has closed, but its brief, misleading glare gave us an invaluable glimpse into the violent, dusty nursery where planets are born. That fleeting phantom world reminds us how much can hide in plain sight, a lesson that applies to the largest forces guiding our own galaxy's destiny. At number 13, we meet the master of our local cosmic current, the Great Attractor. This is not a single object, but a colossal gravitational anomaly, a point in intergalactic space with the mass of tens of thousands of Milky Ways, pulling our entire galaxy and our entire local group of galaxies toward it at a breathtaking speed of over 14 million miles per hour. We are all caught in a river of galaxies flowing toward a waterfall we cannot see. The challenge in solving this mystery is profoundly ironic. The direction of this pull points toward the constellation Norma, a region that lies directly behind the dense, dusty plain of our own Milky Way galaxy. This area is so choked with cosmic gas and stars that it is known as the zone of avoidance, a place where optical telescopes see only a murky, impenetrable wall. For decades, the Great Attractor was a name for a force whose source remained a frustrating silhouette, a gravitational whisper from behind a curtain. To peer through this veil, astronomers had to use instruments that see in wavelengths beyond visible light. X-ray and radio telescopes, which can penetrate the dust, began to map the hidden architecture. What they found behind the curtain was not one monolithic structure, but a layered cosmic metropolis. The first major landmark is the Norma cluster, a dense gathering of hundreds of galaxies, a significant concentration of mass that accounts for a portion of the gravitational tug. But the story does not end there. Looking even farther past the Norma cluster, surveys revealed an even more immense structure, the Shapley supercluster. This is one of the largest known assemblies of matter in our observable universe, a sprawling megalopolis containing dozens of massive galaxy clusters, all bound together by gravity. The combined pull of Shapley, along with the intervening Norma cluster and other concentrations of mass in what is called the Laniakea supercluster, is likely the true, distributed source of the attraction. The Great Attractor, then, is less a single destination and more a direction, a focal point in the uneven landscape of our cosmic neighborhood where the gravitational hills are steepest. We are not falling into a black hole or a single dark overlord. We are sliding down a slope in the fabric of the universe, a slope created by the accumulated weight of countless galaxies stretching over hundreds of millions of light years. This realization transforms the mystery from a search for a hidden monster into a mapping of the grand, invisible topography of our local cosmos. Our journey toward it is a voyage down a river whose source is the entire history of structure formation since the Big Bang. That river of galaxies pulls us toward an unseen destination, but one signal seemed to aim directly for us. At number 12, we have the single most tantalizing blip in the history of the search for extraterrestrial intelligence, the WOW signal. In the summer of 1977, a radio telescope at Ohio State University known as the Big Ear was silently scanning the sky, methodically listening to the cosmic radio whisper. On August 15th, the routine was shattered. For 72 seconds, the telescope's receiver recorded a signal so powerful and so peculiar that it spiked completely off the charts. It was not random noise. It was a focused, narrowband radio burst, a pure tone screaming out of the constellation Sagittarius. When volunteer astronomer Jerry Amon reviewed the computer printout days later, he was stunned. Circling the alphanumeric sequence that represented the signal's incredible intensity, he simply wrote one word in the margin: "Wow." The signal's characteristics were what made it so compelling. It was observed on a frequency of 1420 MHz, which is the emission line of neutral hydrogen, the most common element in the universe. This is precisely the frequency band that scientists had long theorized an advanced civilization might use to broadcast its presence, a universal channel carved out of the cosmic static. Furthermore, the signal's shape matched exactly what you would expect from a distant, fixed source passing through the telescope's narrow field of view, rising in intensity for 36 seconds as the Earth's rotation brought it into focus, then fading away for 36 seconds as it drifted out. It was textbook perfect, and then it was gone, despite decades of follow-up observations by countless telescopes, including targeted searches of the same patch of sky, the WOW signal has never been heard again. Its one-time, brilliant shout has echoed through the decades as the great cosmic tease. The quest for an explanation has covered the spectrum from the mundane to the extraordinary. For years, a leading natural hypothesis pointed to a passing comet. In 2017, an astronomer suggested the signal could have been caused by the hydrogen clouds surrounding two specific comets that were in the right part of the sky at the time. This theory, however, was quickly and thoroughly contested by other scientists, who pointed out that comets were not in the telescope's field of view that night, and that such cometary hydrogen clouds are not known to produce strong, narrowband signals at that frequency. The comet explanation now holds little weight. Other natural possibilities include a brief, cataclysmic event like a star being ripped apart by a black hole, or an unusual form of radio interference that mimicked an astronomical source, though the specific frequency and profile make terrestrial interference seem unlikely. Of course, the possibility that lingers in the imagination is that it was exactly what it appeared to be, a transient, targeted beacon from another intelligence. A deliberate hello that flashed once and then fell silent, either because the transmitter stopped or because we simply were not listening in the right place at the right time again. The WOW signal endures not because it solved a mystery, but because it perfectly embodies one. It is the ghost in the machine of the cosmos, a single data point of profound ambiguity. It is the reason we keep listening, scanning the endless noise, hoping to once more hear a shout that makes us stop and write WOW in the margins of history. The search for alien signals often listens for deliberate patterns, but sometimes the cosmos broadcasts a distress call instead. At number 11, we have a world in its death throes, an exoplanet named KIC 125575548b. This is not a stable, rocky world like Earth, but a planet being actively torn apart, leaving a colossal trail of its own remains across the void. Orbiting astonishingly close to its host star, this doomed world completes a full revolution in just 15 hours, so near that its surface is likely a broiling ocean of molten rock. The intense stellar radiation and heat are literally boiling the planet away, vaporizing its surface and blasting the material into space. This creates a vast, comet-like tail of dust and gas that stretches for millions of miles behind it, a funeral shroud forming in real time. The most compelling evidence for this dramatic evaporation comes from the way the planet transits or passes in front of its star. When astronomers first studied the light curves from the Kepler telescope, they saw something bizarre. The dips in starlight were not clean and consistent. They were erratic, changing shape and depth from one orbit to the next. Sometimes the star would dim by a little over 1%, other times by more than 8 times that amount. This variability is the signature of a chaotic, evolving dust cloud. The planet itself is likely small, perhaps no larger than Mercury, but the cloud of debris it sheds is enormous and constantly shifting. As the planet hurtles around its star, this swirling, opaque cloud of silicate dust and vapor sometimes passes in front of the star ahead of the planet, sometimes behind it, creating an irregular silhouette that blocks a wildly different amount of light each time. Scientists estimate the planet is losing mass at a staggering rate, perhaps hundreds of thousands of tons of material every second. At that pace, this world may not have more than 100 million years left before it is completely evaporated, reduced to nothing more than a faint, diffuse ring of dust that will eventually spiral into the star. For us, this offers an incredibly rare window. Planetary formation is a process that takes billions of years, and the final stages of a planet's life are usually hidden from view. Here, we are catching a planet in its final act, a celestial sandcastle being washed away by the tide of its sun. KIC 125575448b is a stark and sobering lesson in the fragility of worlds, proving that even something as seemingly permanent as a planet is just a temporary arrangement of matter in a universe of constant, violent change. The silent evaporation of a world is a slow farewell, but some stars receive a far more violent goodbye. At number 10, we meet a stellar fugitive, a runaway star officially catalogued as SDSSJ 090745.0 plus 024507. This is not a star moving with the serene flow of the Milky Way's rotation. This is a bullet, a cosmic projectile screaming out of our galaxy at a speed exceeding 1.5 million miles per hour. At that velocity, you could travel from the Earth to the Moon in under 15 minutes. This star is not just fast, it is unbound, moving with enough velocity to completely escape the gravitational grip of the entire Milky Way, destined for the eternal, empty darkness between galaxies. Its incredible speed points to a single, terrifying origin story, a close encounter with the monster at the heart of our own galaxy, the supermassive black hole Sagittarius, a star. Picture this star once orbiting peacefully in the dense, chaotic stellar cluster surrounding the galactic center. Through a gravitational dance of chance, it found itself in a binary pair swinging dangerously close to the black hole's event horizon. In that encounter, the immense tidal forces of Sagittarius, a star, ripped the binary apart. One star was captured, doomed to orbit or be consumed, while the other, our runaway, was violently flung away like a stone from a sling, receiving a tremendous gravitational kick that sent it rocketing outward. This process, known as the Hill's mechanism, is nature's most powerful catapult. By tracing the star's path backward through space, astronomers can confirm its trajectory leads right back to the galactic core, the scene of the crime. But this stellar fugitive carries more than just speed. It carries a chemical fingerprint of its birthplace. Spectroscopy reveals it is rich in heavy elements, far more so than our own sun. This metallicity tells us it was born in the galactic center, a region where generations of violent supernova have enriched the cosmic environment with the forged elements of stellar life and death. It is a piece of the galaxy's most extreme neighborhood blasted out into the hinterlands. Now it travels alone. It will cross the galactic halo and then breach the diffuse boundary of the Milky Way, entering the intergalactic medium where the space between galaxies is nearly a perfect vacuum. For billions of years, it will journey through this profound nothingness, a lonely beacon with no planets, no companion stars, and eventually, no recognizable constellations in its sky. Its fate is to grow old and die in utter isolation, its light fading into the abyss. This runaway star is more than a curiosity, it is a messenger. By studying its speed and composition, we gain indirect evidence of the dynamic, violent environment surrounding our galaxy's central black hole. It is a natural probe sent to tell us about forces too distant and dangerous to observe directly. In its solitary exile, it carries the indelible mark of home, a permanent record of the cataclysm that set it free into the endless night. A star's violent escape leaves a trail of solitude, but some stellar deaths weave a web of breathtaking intricacy. At number 9, we encounter the Red Spider Nebula, a planetary nebula in the constellation Sagittarius that looks less like a gentle cloud and more like the explosive aftermath of a cosmic detonation. Its popular name is perfectly apt, for it displays a complex, symmetrical structure of rippling waves and delicate filaments, resembling a vast crimson web spun across 3,000 light-years of space. This is not a quiet fading, but a furious and precise act of self-destruction. At the heart of this luminous chaos sits one of the hottest white dwarf stars ever discovered, a stellar ember with a surface temperature exceeding 500,000 degrees Fahrenheit. This tiny, ferocious core is the engine of the nebula's beauty, unleashing two devastating forces. First, it bombards its own expelled outer layers with intense ultraviolet radiation, causing the vast clouds of hydrogen gas to fluoresce with that deep, haunting red glow. Second, and more dramatically, it emits supersonic winds of unimaginable power. These are not gentle breezes, but hurricane-force jets of particles screaming outward at speeds over 300 kilometers per second, nearly 1,000 times faster than the winds of Earth's most powerful storms. It is these winds that sculpt the nebula's impossible geometry. As they slam into the slower-moving shells of gas ejected earlier in the star's death throes, they create shock waves. These shock waves ripple through the nebula, compressing and heating the gas, carving out the intricate lanes and forming the symmetrical, wing-like lobes that stretch across the void. The result is a dynamic, evolving sculpture, a snapshot of fluid dynamics operating on a stellar scale. The nebula's symmetrical shape hints that the white dwarf might have a companion star, its gravity helping to focus these winds into two opposing jets, like a cosmic blowtorch cutting through smoke. Watching the red spider is like watching a slow-motion explosion frozen in luminous gas, a testament to the fact that even in its final moments, a star can exert a control and a fury that creates patterns of shocking complexity. It is a reminder that destruction and creation are often the same process, and that from a star's violent end, a temporary masterpiece is born. A nebula can be both a canvas and a casualty of its own creation. At number 8, we find the ghost of Cassiopeia, a faint, ethereal cloud officially known as IC63. Drifting over 600 light-years away in the constellation of the Queen, this wispy structure is locked in a beautiful losing battle. Its tormentor and its source of light is the same object, the nearby, intensely hot blue variable star Gamma Cassiopeiae. This star is a celestial powerhouse, spinning so fast it flings material from its equator and bathing its surroundings in a torrent of high-energy ultraviolet radiation. The ghost is caught in this stellar gale. It is a hybrid nebula, part reflection and part emission, and its dual nature tells the story of its struggle. The delicate blue portions are reflection nebulae, where fine cosmic dust simply scatters the star's intense blue light, like fog illuminated by a car's high beam. The faint red glow is something else entirely, the signature of emission. Here, the star's ultraviolet radiation is so powerful it strips electrons from the hydrogen atoms within the cloud itself. When those electrons eventually recombine with protons, they release a characteristic crimson photon, causing the gas to fluoresce with its own eerie light. So the nebula is both a mirror and a lamp, but it is a lamp that is burning its own fuel. This is the cosmic battle, a constant push and pull between illumination and erosion. The fierce radiation from Gamma Cassiopeiae is not just lighting the ghost, it is actively destroying it, heating and dispersing the very gases that make it visible. The nebula's shifting, phantom-like shapes are sculpted by this relentless pressure, a constantly changing silhouette in the stellar wind. Structures like the Ghost of Cassiopeia are transient masterpieces. They may shine for only a few tens of thousands of years, a mere blink in cosmic time. Eventually, the radiation will win, dispersing the delicate cloud into the interstellar medium, leaving nothing behind but the brilliant, uncaring star. This cycle is fundamental. The death of one structure becomes the raw material for the next. The atoms being blown away from this ghost today may one day collapse under gravity in another part of the galaxy, heated by a new star, and form another nebula in a cycle that has repeated for billions of years. We are witnessing a single, beautiful frame in an endless reel of stellar recycling, where beauty is a fleeting side effect of perpetual, violent change. The delicate, fading ghost of a nebula stands in stark contrast to a stellar corpse that refuses to fade quietly. At number 7, we find the furious heart of a cosmic wreck, the pulsar at the center of the Crab Nebula. This is not a quiet ember, but a dynamo of almost incomprehensible power. The nebula itself is the expanding debris field from a supernova that was so bright it was recorded by Chinese and Arab astronomers in the year 1054 AD, visible in the daytime sky for weeks. At the very spot where that star died, something incredible was born. The core of the star collapsed into a neutron star, a city-sized sphere of pure nuclear matter so dense that a single sugar cube of its material would weigh as much as a mountain. But this particular neutron star is special. It is a pulsar and it spins. It completes a full rotation 30 times every single second. With each spin, it sweeps a beam of radiation across the cosmos like a lighthouse, and for a fraction of a second, that beam points directly at Earth. We see it as a pulse of radio waves, visible light, and even gamma rays, flashing with a clockwork precision that rivals our most accurate atomic clocks. This rapid spin is the key to everything. The pulsar is a celestial powerhouse, a natural particle accelerator of staggering efficiency. Its intense magnetic field, trillions of times stronger than Earth's, rips electrons from its surface and flings them outward at nearly the speed of light. These electrons then spiral along magnetic field lines, emitting a brilliant, shimmering glow as they move, a process known as synchrotron radiation. This is the engine that illuminates the entire Crab Nebula. The ghostly, filamentary tendrils of gas we see in photographs are not just passively glowing from the ancient explosion. They are being continually re-energized, shocked, and set aglow by this relentless torrent of particles from the central pulsar. It is a closed circuit of cosmic violence, where the spinning remnant of the dead star pumps energy back into its own funeral shroud, keeping it brilliant 1,000 years after the initial cataclysm. For scientists, the Crab pulsar is a gift, a natural laboratory for studying physics under conditions we could never hope to recreate. By watching its pulses, we can test theories of gravity, study the behavior of matter at nuclear density, and understand how particles behave in the most powerful magnetic fields in the universe. It is a beacon that does more than just shine. It teaches, pulsing out lessons about the most extreme states of matter from the heart of a beautiful catastrophe. The precise clockwork of the Crab pulsar measures a universe we think we understand. But what if the very first light of creation itself contains a flaw? At number 6, we confront a cosmic bruise, a region of the sky known simply as the cold spot. This is not a place you can point a telescope at, for it is etched into the oldest photograph in existence, the cosmic microwave background. This faint, uniform glow is the cooled remnant of the Big Bang's first fire, a snapshot of the infant universe when it was just 380,000 years old. Most of this background radiation varies by only tiny fractions of a degree, a testament to the universe's smooth, even start, but the cold spot is different. It is a vast circular patch in the constellation Eridanus that is significantly colder than its surroundings, a chill that extends across a staggering 1.8 billion light-years. According to our best models of cosmic inflation and structure formation, a fluctuation this large and this cold is staggeringly improbable, like rolling a dice and getting the same number 100 times in a row. It is an anomaly that should not exist, a potential crack in the foundation of modern cosmology. Scientists have proposed two radically different explanations, each more mind-bending than the last. The first is a cosmic sinkhole, a supervoid. If an immense, mostly empty region of space, a void far larger than the Boötes Void we discussed earlier, existed between us and the cold spot, it could create the cold illusion through a process called the integrated Sachs-Wolf effect. As light from the cosmic microwave background passes through such a vast underdensity, it loses energy climbing out of the void's weakened gravitational well, shifting to longer, cooler wavelengths. The problem is, surveys have found a large underdensity in that direction, but it does not seem nearly vast or empty enough to account for the extreme temperature drop. The void explanation stretches our understanding of structure, but the alternative stretches reality itself. The second, and far more exotic, idea is that the cold spot is a collision scar. In some models of the multiverse, our universe is one bubble in an endless, frothing foam of other expanding bubbles. If, during its inflationary infancy, our universe brushed against or collided with a neighboring bubble universe, the energy of that impact could have left an imprint on our cosmic microwave background, a kind of cosmic birthmark from a sibling reality. This collision would have drained energy from that particular region of our early universe, leaving it permanently cooler. The cold spot, then, could be tangible evidence that our cosmos is not alone, that we reside in a multiverse. Whether it is a titanic void or a bruise from another reality, the cold spot remains one of the most significant and puzzling anomalies in all of science. It is a whisper from the very edge of everything we can observe, suggesting that our map of creation, drawn from that first perfect light, might have a tear in its parchment. That cosmic cold spot challenges the very foundations of our universe, while another star seems to defy the basic rules of chemistry itself. At number 5, we find a stellar chemist's nightmare, Tabby Star. This seemingly ordinary star in the constellation Centaurus hides a spectroscopic signature so bizarre it has baffled astronomers for over half a century. When we analyze the light from a star, we can break it down into a rainbow, a spectrum crossed with dark lines that act as a fingerprint, revealing every element present in its atmosphere. The spectrum of Tabby Star is unlike any other. It is littered with the signatures of highly radioactive, short-lived elements that simply should not be there. We see strong lines for promethium, an element with no stable isotopes, whose longest-lived form decays away in just 17.7 years. We detect technetium, another element that is unstable on any stellar timescale. The star's atmosphere is also overflowing with rare earth elements like strontium, holmium, and neodymium, at concentrations hundreds or even thousands of times higher than in our own sun. This is the equivalent of finding a perfectly preserved, steaming cup of coffee in the middle of an ancient archaeological dig. The chemistry is all wrong for the environment. These radioactive elements have half-lives measured in mere years, decades, or centuries, cosmic eye blinks. They cannot have been forged in the star's core and transported to the surface, as that process takes millions of years, by which time they would have long since decayed into other stable elements. So how are they continuously appearing on the surface? One leading natural theory is as strange as the observation itself. it proposes the presence of an unknown, super-heavy element somewhere in or around the star. This hypothetical element, with an atomic number far beyond anything on our periodic table, would itself be unstable, but as it decays, it would do so through a long, complex chain of radioactive daughter products, precisely spitting out the exotic isotopes we see, like promethium and technetium, as transient byproducts. In this scenario, the star's atmosphere is being constantly seeded by the radioactive decay of this unseen, heavier parent element, a natural nuclear waste dump operating in real time. Of course, such a peculiar and persistent anomaly invites more speculative ideas. Some have wondered if we are seeing evidence of nuclear activity that is not natural. Could the spectral lines be a signature of deliberate element disposal? It is a fringe thought, but the idea that an advanced civilization might use their star as a processing facility or a repository for the byproducts of nuclear technology has been floated, making Przybylski's star a perennial favorite in discussions of potential technosignatures. Yet most scientists lean toward a natural, if profoundly unusual, explanation, perhaps involving bizarre magnetic fields or accretion from a neutron star companion that has been utterly pulverized into radioactive dust. Despite decades of study, no theory has yet provided a fully satisfactory answer. Przybylski's star remains a locked cabinet in the cosmic chemistry set, its contents a dazzling, impossible mixture that defies our understanding of how stars live and die. It is a reminder that sometimes the universe is not just stranger than we imagine, it is stranger than we can imagine, presenting a puzzle written in the unstable atoms of a star's fading light. A star with impossible chemistry tests the laws of physics, but our own solar system may be hiding a ghost that bends the laws of orbital motion. At number 4, we confront the most tantalizing detective story in modern astronomy, the Planet 9 hypothesis. Beyond the orbit of Neptune, in the cold, dark frontier of our solar system, a population of icy bodies called extreme trans-Neptunian objects drift in the void. Their orbits are the clues, and they are telling a strange, consistent story. Astronomers studying these distant objects noticed something peculiar. Their elongated orbits are not randomly oriented. Instead, they appear to be clustered as if something massive, something with a gravitational hand, is herding them, aligning their paths in space. The simplest explanation, the one that fits the mathematical models, is the presence of an unseen planet. This would not be a small, rocky world, but a true giant, a super-Earth or a mini-Neptune with a mass 5 to 10 times that of our own planet. Its proposed orbit is staggering, a long, elliptical path that takes it on a lonely journey lasting between 10,000 and 20,000 years. At its closest approach, it might come within 200 to 300 astronomical units from the Sun, still several times farther out than Neptune. At its most distant, it could retreat to over 1,000 astronomical units, a place of near absolute darkness and cold. Finding this phantom world is the ultimate challenge. It moves incredibly slowly across the sky, and at such vast distances it would reflect almost no sunlight, making it a faint, crawling dot against a backdrop of millions of stars. The search is a monumental task of computational astronomy and painstaking observation, using the world's most powerful telescopes to scan slivers of the predicted orbital path, looking for that one pixel of light that does not belong. The implications of a discovery, however, would be revolutionary. Planet 9 would not just be a new member of our planetary family, it would be the key to unlocking several solar system mysteries. Its immense gravitational influence could explain the peculiar, clustered orbits of those distant icy bodies. More profoundly, it might solve the long-standing puzzle of why the entire solar system is tilted. The Sun's equator and the average plane of the planet's orbits are misaligned by about 6 degrees. A massive, inclined Planet 9, acting over billions of years, could have gently pulled the entire system off kilter. Its very existence would force us to rewrite the history of our cosmic neighborhood. How did such a large planet get so far out? It may be an exiled core of a gas giant, flung outward during the solar system's chaotic early migrations, or perhaps it is a captured rogue planet, an interstellar orphan adopted by our sun's gravity in its youth. The hunt for Planet 9 is a testament to the power of prediction, a modern echo of the calculations that led to the discovery of Neptune itself. It is a reminder that our own backyard, the solar system we think we know, may still hold giants in the shadows, quietly shaping the dance of worlds from the frozen dark. The search for a hidden giant in our own solar system reveals how much can hide in darkness, but some structures are so dark they are defined by their absence of light. At number 3, we meet a cosmic ghost, an object known as HI1225+01, a dark galaxy. This is not a glittering spiral or a blazing elliptical, but a vast, silent reservoir of hydrogen gas drifting through the void, holding the mass of billions of suns yet containing almost no stars. It is a shadow of a galaxy, a blueprint for cosmic structure that was never filled in. Discovered through its faint radio emissions, this cloud of cold, neutral hydrogen is the primary fuel for star formation. Yet here, for reasons we do not fully understand, that fuel has simply refused to ignite. The result is a celestial paradox, a massive object that is almost entirely invisible, a dark smudge on the radio sky where there should be a blaze of stellar light. The mystery lies in its origin. Is this a failed galaxy, a pristine relic from the early universe that somehow never gathered its gas densely enough to trigger the collapse into stars? In this scenario, it is a cosmic stillbirth, a structure that acquired the dark matter halo needed to collect gas, but where the conditions for star formation were never met, perhaps because the gas remained too hot or too turbulent. Or is it a victim of cosmic violence? Perhaps it was once a normal, star-forming dwarf galaxy that had a close encounter with a larger neighbor. The gravitational tides from that interaction could have ripped away its stars while leaving the more diffusely spread hydrogen gas behind, creating a stellar ghost haunting its own gaseous corpse. A third, simpler possibility is that it is not a galaxy at all, but just an unusually large, isolated cloud of primordial gas, a leftover fragment from the formation of the cosmic web. Determining the truth is crucial because dark galaxies are not just curiosities, they are vital tests for our theories of how the universe builds structure. Our standard model of cosmology relies heavily on dark matter. Galaxies are thought to form when normal matter, like hydrogen gas, falls into the gravitational wells created by clumps of this invisible substance. A true dark galaxy, one with a massive gas cloud but no stars, would be the perfect laboratory. By studying its rotation and distribution, astronomers could map the shape and density of its dark matter halo with unprecedented clarity, free from the complicating effects of stellar winds and supernova explosions that churn up normal galaxies. It would be a pure sample of the universe's hidden skeleton. Furthermore, if such objects are common, they could solve a long-standing mystery, the missing satellite problem. Our simulations of galaxy formation predict that thousands of small dark matter clumps or subhalos should orbit large galaxies like the Milky Way. We only see a fraction of that number as visible dwarf galaxies. Could the rest be these dark, starless halos, the silent majority of cosmic structure? HI1225+01 and objects like it represent a frontier. They challenge us to see the universe not just by the light it emits, but by the gravity it exerts and the faint radio whispers of its most basic ingredient. They are reminders that the cosmos is built more from shadow than from light, and that the most common structures might be the ones we have to work hardest to perceive. That silent, starless galaxy is a monument to what does not shine, but at the very heart of our own Milky Way, something is shining far too brightly. At number 2, we have the galactic center gamma ray excess, a mysterious fog of high-energy light that envelops the core of our galaxy. For over a decade, telescopes like the Fermi Gamma Ray Space Telescope have mapped this region, expecting to see gamma rays from known sources, like the supermassive black hole Sagittarius A star or the remnants of ancient supernova. Instead, they found something else entirely, a spherical, diffuse haze of gamma ray radiation extending thousands of light years from the galactic center. This glow is too smooth, too symmetrical, and too energetic to be easily explained by any catalog of ordinary objects. It is a cosmic background hum with no clear source, a persistent, luminous question mark at the crossroads of our galaxy. The hunt for an explanation has led scientists down two very different paths, each with profound implications. The first and most tantalizing path points to the invisible fabric of the cosmos itself, dark matter. According to this theory, the galactic center is the densest reservoir of dark matter in the Milky Way. If dark matter particles are their own antimatter counterparts, they could annihilate upon collision, converting their mass directly into energy and producing a spray of gamma rays. The smooth, spherical shape of the excess matches predictions for such a dark matter halo. This glow could be the first indirect detection of dark matter particles, a faint but monumental signal from the universe's most elusive substance. It is a ghost finally casting a shadow made of light. The second path is more conventional but no less fascinating. It suggests the glow comes not from one exotic source, but from a vast, unseen population of thousands of millisecond pulsars. These are old neutron stars spun up to incredible speeds, acting as steady lighthouses of gamma radiation. If they are too faint and too crowded together at the galactic center for our telescopes to resolve individually, their combined emission could perfectly mimic a smooth, spherical haze. This would make the excess not a revelation of new physics, but a testament to the sheer, unresolved stellar archaeology of our galaxy's ancient core. Currently, the evidence is frustratingly balanced. Detailed analyses of the excess's structure show slight irregularities, tiny clumps that could be the fingerprints of individual pulsars hiding within the fog. Yet, follow-up searches with radio telescopes have failed to find the expected number of these pulsars. The mystery endures because both answers are revolutionary in their own way. One reveals the fundamental nature of most of the matter in the universe. The other unveils a hidden metropolis of stellar corpses, rewriting the history of star formation and death in the galactic downtown. This excess is more than just an anomaly, it is a frontier. It represents the edge of our understanding, where the known astrophysics of dead stars meets the unknown physics of the dark universe. Every new observation, every more detailed map sharpens the question: is this glow the signature of something profoundly new, or simply the collective whisper of countless old things we have yet to see? The answer lies in that persistent spherical haze, a luminous riddle waiting at the heart of everything we call home. And so we arrive at the final, breathtaking entry on our list, number 1, the Pillars of Creation. Rising from the heart of the Eagle Nebula, 7,000 light-years away, these are not merely clouds. They are cosmic cathedrals, colossal spires of cold molecular gas and interstellar dust, each stretching several light-years from base to tip. Within their shadowy folds, lit only by the fierce ultraviolet glare of nearby newborn stars, the universe is busy at work. These pillars are stellar nurseries, and the process at hand is both beautiful and violent. The same radiant energy that illuminates their majestic forms is also eroding them, a phenomenon called photoevaporation. Intense stellar winds are blowing away the lighter gases while simultaneously compressing denser knots within the pillars. Under this immense pressure, those knots collapse under their own gravity, igniting into new stars. We are witnessing creation sculpted by destruction, a star forge where the tools are light and stellar wind. Yet the most profound strangeness of the pillars of creation is a trick of time and light. The Hubble Space Telescope's iconic image is a message from the distant past. Given their vast distance, the light we see left the Eagle Nebula 7,000 years ago, and astronomers studying other wavelengths have detected evidence of a supernova shockwave that likely swept through that region long ago. This leads to a haunting possibility. The magnificent structures we admire, these symbols of birth and endurance, may have already been vaporized, shattered by that cataclysmic blast from a neighboring star's death. We are looking at a ghost, a memory of a place that may no longer exist in its pictured form. But this is not an end, it is a revelation of the cosmic cycle. The material from those shattered pillars, now enriched with heavy elements forged in the supernova, will be scattered across space. That dust and gas will eventually coalesce again, under gravity's patient pull, into new clouds, new pillars, and new stars. Perhaps even stars with rocky planets, and on those planets, chemistry complex enough to one day look up and wonder. The pillars of creation, whether they still stand or not, are the ultimate symbol. They represent the beautiful, transient, and violent dance that defines everything. In their towering forms, we see the universe's endless rhythm, where every end is a seed for a new beginning, and where light itself carries both the image of life and the echo of its passing. From ghostly galaxies to evaporating worlds, our journey through these 25 cosmic oddities reveals a universe far stranger than any fiction. We have wandered through voids of terrifying emptiness, gazed upon stars with impossible chemistry, and witnessed the slow, beautiful violence of creation and destruction. Each object, from the geometric perfection of Hoag's object to the predatory dance of the Black Widow pulsar, is a question written in light, gravity, and dust. These are not mere curiosities, they are the signposts at the frontier of human knowledge, the anomalies that force us to rethink our most fundamental assumptions. Every mystery solved opens 10 more, driving the relentless engine of science forward. They remind us that the cosmos is not a static museum, but a dynamic, evolving, and deeply weird place where the rules are still being written. This is the true wonder of exploration. The universe constantly challenges us to look deeper, think bigger, and embrace the unknown. So tell us, which of these cosmic marvels captured your imagination the most? Was it the diamond planet forged from stellar death, or the haunting wow signal that shouted once and vanished forever? Let us know in the comments below. If you enjoyed this voyage to the edge of understanding, be sure to give this video a like and subscribe for more journeys into the deepest mysteries of space. The universe is waiting, and its next great secret is just one discovery away.